Welcome to garyclarke.tech and my latest Docker and PHP course. The very first tutorial which I made for YouTube was about Docker and PHP, and so I thought to coincide with my new look channel, it will be a good time to revisit the subject because a lot can change in 2.5 years. My recordings have got a lot better, and also in the world of tech, things change very quickly. Because the first one was quite a popular tutorial, I've decided that this time I'm going to double down and go more in depth. There are going to be greater explanations. I'm also going to consider alternatives to the solutions I provide. And one other thing is that I've just had the time to look around and see the kind of things that people are struggling with. And so we're going to try and cover some of those too. I don't want to use this course to just provide you with a single solution which you kind of understand. The whole goal of this course is to educate you so that you are empowered, and if you needed to, you'd be capable of coming up with a solution of your own. These are the chapters that this recording is broken down into. Any bonus chapters which I create based on user feedback or requests will be added to the garyclarke.tech site. There is a repository for this on GitHub. Just look for garyclarke/docker-php. I think you'll find the repo really useful because it means you can just go and copy and paste the application code, and that means you'll be able to stick to just doing the Docker stuff. Each branch in the repo corresponds with a chapter, and I'll include that info in the recording and also in the description below this video. So make sure you check out the description below the video. I'll put a load of useful information in there for you also. And so this is the system that we are going to create, or to use the correct Docker terminology, this is the network that we are going to create. If you'd like a mental reference to compare this against, then think of something like a pre-configured stack, such as a LAMP stack. This is a system composed of an Apache server, MySQL database, and PHP running on a Linux operating system. You can swap the OS for Mac and it becomes a MAMP system, or you can swap for Windows and it becomes WAMP. You get the idea. But with Docker, however, this network which we create will be portable and able to be spun up on any operating system. So we can forget about that consideration and concentrate on the component parts. These component parts will be all individual containers. Here I've swapped Apache for Nginx. That decision will be explained when we get to it, and I've added Redis, which we can use for caching and other cool Redis-y things. Now this bit's important. In order to follow along, you're going to need something called Docker Desktop, which you can get from this address here, docs.docker.com/getdocker. If the address changes, just Google get Docker Desktop, and this is what you need. And so it has installations for whichever operating system you use. As you can see, we've got Mac, we've got Windows, and we've got Linux. So get that, install that, and then you'll have everything you need. We're going to piece all of this together step by step, and so we'll be checking and testing our work as we go. Every step will be explained, each decision will be rationalized, and so there'll be no mystery content. And it's going to be a lot of fun, it's going to be educational. Let's make a start now by creating something called a Docker Compose file. With Docker, you have to think of your collective application as a network of services, because that's exactly what it is. And each of those services is its own containerized component. They are all individual. In order to network them and make them communicate with each other, we need to have some kind of mechanism. Luckily for us as developers, we can do this with code, and we can do it with a file called a Docker Compose file. And so that's what we're going to create here. Here I'm starting with a brand new empty project. When I say it's empty, there is actually one file already in there, but that's just a git ignore file so that I ignore all the files which my editor adds for me. And what I'm going to go and do is create my first actual real file in there, and that will be my Docker Compose file. So new file, and this will be called docker-compose. Something to note about the name is you do not have to call it Docker Compose .yaml. However, if you want to use things like push into Elastic Beanstalk or things like that, a lot of services will have a convention in place where you do need to name it like this. By default, if I run docker compose commands, it will look for a file called dockercompose.yaml by default. However, I can specify a different file name when I go and run my Docker Compose commands, and it will use the file name which I specify. But for the time being, we're going to stick with the default. But later on, when we go to creating different Docker Compose files for different environments, then we'll create ones with different names. I think what I'll do with this series, like I've done with other series in the past, is I shall name my branches after what I'm working on. For example, with this one, what we'll do is we'll create a branch for this. So git add dot for git add all, git commit, and we'll just commit this. Of course, if you want to know more about Git, then check out my full Git and GitHub course at garyclarke.tech. So I'm creating a new branch here and I'm just calling it create docker compose. Okay, and then each subsequent step that we do, I'll create a new branch for it. And so that way, if you just want to go and follow the steps on GitHub, then it'll be nice and easy for you to do that kind of thing. Now we need to define our network of services. We can do that by starting out with a services key. And then here, you just create all your different components, all your different services. So we said that we want to have PHP, Nginx, MySQL and Redis. In this instance, what I think I'm going to do is I'm going to work on Nginx first, because once we've got a web server up and running, then it means the other parts will be more easy to demonstrate. As for naming these services, what you'll see a lot of the time is that people will name them more after the service which they provide rather than the technology which is powering it. And that kind of makes sense, because say for example I name this Nginx for my web server. What if I had another Nginx server which was serving something else? In that case it will become ambiguous. I wouldn't be able to name them both the same, and so it's best to actually name them with something meaningful like the service which they are performing. And so in this case we'll just call this web, and the Nginx will be our web server. In order to build this Nginx container, I'm going to need something called an image, and an image is basically your blueprint for how your container should be built. Think of PHP, something like classes, where you create an object using the class as its blueprint. Well, this is pretty much exactly the same thing. You take the image and then Docker reads that image in order to build the container the way that it should be built. And so this key here is image, and then I need to specify which image. And images are located in a registry. You can have your own private registries, or you can have a centralized registry. If I don't specify a particular registry in order to do this, an address, then what Docker will do is it will go and look for it in the Docker Hub registry, which is like the Docker default centralized registry. Think of when you're using PHP and Composer, then packages is like a centralized location where Composer will go and look for packages. This is exactly the same kind of thing. And the image I'm going to look for will be called Nginx latest. Tag is just a way of versioning things. So here we have Nginx, which is the program, and then latest, which is the tag, i.e. the version. Shortly, when we come and create our own image, what we're going to do is we're going to have a look at something called Docker Hub, and I'll show you some tags then. And believe it or not, there's actually enough information here for me to be able to go and run a docker compose command, and for Docker to go and get the image from the registry, pull it down onto my computer and build a container from it. However, it will be very hard for me to demo anything. In order to demo this, I need to expose a port from my local machine into the container so that we have that mapping between the container and my computer. The way that we can do that is by saying ports, and here you can specify an array. That's what the little dash means in a YAML file, but we're just going to have the one mapping, and that will be 80 to 80. And so what this means is port 80 on my local machine, my local host, will map to port 80 on the container. And so with that, we now have like a gateway where we can look into the container from our local machine. And that will make more sense when we go and do that in a second. Now let me show you the command that we need to run in order to build this network of services. Obviously we only have one service in there, but it is still a network of services nonetheless. And that command is docker compose and then up. Hit enter. And so what's actually happening here is that it is reaching out to the Docker registry, getting that image and pulling it down, extracting it and pulling it down onto my computer. You'll only have to do this once, because once you've been and got that image and it's on your computer, the next time that you run Docker up, it will just simply go and get the image straight from your computer where it is located. All that has happened, so all I need to do now is go and visit localhost:80, hit enter. Welcome to Nginx. So as you can see, Nginx web server is successfully installed and working. Before we finish this one off, let me show you a couple of commands which we can use to inspect things and to see what is running. First off, if you want to see which containers are running, you can say docker ps. So apologies that I've made this quite small. It's in order to fit it all on one line, because as you can see there's quite a lot of information there, but we have a container ID, and so when a container is created, it's created with an ID. It shows you the image which has been used in order to create the container, how long it's been up, status, shows you any ports which are mapped. So here you can see that port 80 on my local machine is mapped to port 80 on the container, and it also gives your container a name. Now you can actually give your containers names yourself by specifying a name, but I just left it, and if you don't leave it then it will come up with a name based on the folder in which it finds itself. The other command that I'll show you is one called docker compose ps, and so that will tell you which services are running, which services, which parts of networks, and so let's run that. And so here we're not actually looking at this as a container, we're looking at it as a web service. Status running, again it tells you which ports are mapped. There is one other place where you can go and check this stuff out, and so with Docker Desktop you can come to this icon at the top here and ask it to show you the dashboard, and then here you have these choices of things that you can look at. And so I'm looking at containers apps, so we have Docker PHP running. If we look inside that, as you can see we have this one container running, Nginx latest. It shows you which images you have. These are all the images which are on my computer, and also something called volumes, and we'll get onto volumes later on. There are two main files in Docker. The first one we've had a look at, that was the Docker Compose, and that's for creating sort of your application as a whole. But now we're going to have a look at another type of file, and that is the Dockerfile, and that is used for creating the images which are used to build your containers. We now have a Docker Compose file that is a single service to that, and that being our Nginx web service. Now what I want to do is add another one for our application, and this is going to be a PHP application, but like I said in the previous one, I'm not going to name it after the technology which is powering this. I'm going to name it after a descriptive name as for what it does, and this is going to represent our app, and all our application files will live inside of this container. So I'm simply going to call this one app. And I could do what we did previously, where I went and got a pre-configured image and just use that. I am going to get a base PHP image, but I want to customize it. I want to add my own extensions to it. I want to do other things such as use Composer to install dependencies using it. And so what I'm going to do here is I'm going to build my own image based on a base PHP image. And so in order to do that, instead of specifying the image that we're going to use, I'm going to actually build it locally. And so I'm going to add a build key, and then in order to build it I need to give Docker some information, and in order to build images Docker needs to read something called a Dockerfile, and so you need to tell Docker where that Dockerfile can be located. So I'm going to say Dockerfile, and here I'm actually going to create a new folder specifically for PHP Docker specific stuff such as config and Docker files. So I'll say PHP, and inside of there I'm going to create a file called Dockerfile. This is a convention, you do not have to call it this, but you'll see in like 99% of cases it is called Dockerfile, or Dockerfile.dev, Dockerfile.prod for production, or some kind of variation like that. Here we're just going to stick to Dockerfile. So I'll hit enter on that. And then back to the Docker Compose.yaml file, I just need to tell Docker Compose where to actually find that now. So we'll say php/Dockerfile. When you go to build your own custom images, you have to start with a base image. So like we used an image for Nginx, we are going to actually start with an image. And so you might be wondering, well, where do we actually find these? How do we know what the names of them are? So you can come to this that I'm looking at here, and it's called Docker Hub, so hub.docker.com, and then you can search for the type of thing that you're looking for. So in our case we are looking for PHP images, so I'll hit PHP, that will take you to the PHP page, and so you'll have this tab overview which tells you a little bit about using PHP Docker images. Also tells you a little bit of stuff about configuration and how to write your Dockerfile, but I'm going to show you how to do that anyway. Have a look through this if you want. You'll definitely come back and use this as a reference when you become more experienced and you want to know more about configuration and things. But for the time being, I'm just going to show you where we can find the tags, basically where we can find our base images. So we have a tab here called tags. And what I'm going to look for is an 8.1 tag. So if I type in 8.1, and I also want FPM because I'm using Nginx, and I'll explain that more to you when we go and do our Nginx configuration. And the one I'm actually going to use is this one here, 8.1-FPM-Alpine. And Alpine basically means that it's a minimalist image with a minimal amount of extra software installed in there, because I'm going to decide for myself which software I want installed, which extensions I want installed in this image. Back in my project, I'm going to click into my Docker file, and so here you can run a bunch of commands. The first one I'm going to run is one which says from, and that means from which image. And the image we are looking for is PHP, so if you remember, you use the name of the vendor first and then the actual image or the image tag. Once you have that base image, then you're in a position where you can run some commands in order to install software, add extensions, for things like if you want to run Composer and pull in dependencies. These are all things that we're going to do, but for the time being I just want to add a PHP extension so that I can use MySQL. And so the command you use in order to run commands is run. And as I'm using a PHP base image, it means I have access to this command here, docker php ext install, which, as the name might suggest, is used for installing PHP extensions. And what I want is pdo MySQL. And for the time being, this will serve our purposes, though we are going to add to it later. So let me just explain something regarding the Docker Compose. When we last ran this Docker Compose up, what happened was it looked at the image and built the container from that. What's going to happen here is it's actually going to look at the fact that we want to build the image first, and it's going to build the image from the Docker file when we run that command Docker Compose up. But what I'm going to show you first is how we can actually build the image in isolation by using a command from the command line. And that command is this, docker build. The option T is to give it a name, so I'm saying Gary Clarke with a tag of PHP 8.1, and then if the Docker file was actually in the folder from which I'm running the command, I wouldn't need to specify a file name like I'm doing here. However, our Docker file is in a PHP folder, so I need to tell Docker where to find it. So the option F means file, and then I'm just saying this is the path to the Docker file, and the dot means that we're building it from this folder location. And so any resources which I wanted in my Docker file, even though I've not actually specified any, Docker would actually go and look for those inside the actual folder where I'm calling this command from. Hope that makes sense. Let's go and run this. Okay, and the reason why I decided to run this is so that I could show you the steps being built. And because we only have 2 steps, it's very easy to see what's happening. So here we have step 1 of 2, where we're going and getting the PHP 8.1 image from Docker, and then we are running this command in order to install the pdo MySQL extension. Then what Docker does is it has all the information that it needs there, it exports the image. Each one of the commands that you put in your Docker file will actually create a layer, and so the image is made up of layers. It then writes the image. As you can see, each image has its own unique hash, and then the final step, it names the image. So as you can see, we have the repository name, so I've named it Gary Clarke, and then the tag PHP 8.1. If I go and run docker images, we can now see that here listed amongst our images, repository Gary Clarke and the tag PHP 8.1. So that's the image which we have just created. And just to be clear on something, we didn't actually have to build that image separately. That will happen when we go and run Docker Compose. However, I thought it would be a good idea to show you the steps and how the images are built, because sometimes you'll run into problems during the build, and if you know where to look and how to pinpoint at what stage things went wrong, that'll really help you out. When we visited this last time, the reason why we're seeing this page is because the default Nginx configuration is actually pointing at this page, and it's just a static HTML page which is on the server. What we want to do is change our configuration to actually point to a location on the server where we're going to start putting our PHP files. First, let me actually show you that original config file, and then you'll be able to mentally make sense of all this stuff. So I'm going to say docker compose up to spin up the network. If I do -d, it means it will do it in detach mode. Basically, that means it'll hand the terminal back to me rather than show me what's actually happening inside the container. Okay, and to actually look inside the container, I'm going to need to shell into there, and that means I'm going to need to know the actual name of the container. So I can do docker compose ps to have a look at my containers. So I have docker php app1 and docker php web1. So if I say docker exec, meaning execute, I'm going to execute a command on my container. -it means interactive, so that means I can interact with my container, and the T, I think that means that I can do it in sort of a terminal style way. It'll give me a prompt. Then I need the name, so I'm just going to copy this, paste that there, and then the command which I'm executing is sh for shell, so this means that I can sort of shell into my container and run commands inside there. Okay, as you can see the little hash there, so I have a prompt, and then I'm just going to print out the content of the existing config file. So I can do that with cat. This is the address. Okay, so I'll not go into the detail just yet, but basically when we hit this root location, it looks in this root public folder for an index.html file, and that is basically the file which you're looking at when we look in our browser. Okay, cool. So our goal in this one is to actually override this config file with our own. First off, let's go and create a public folder for our application. So I'm going to create a new folder at the root level. I'll call this app, and then inside of there I'm going to create one called public, and then here we're going to create an index file, index.php, and inside of here I'm just going to echo out good old hello world. Next, what I want to do is create my Nginx config file so that I can actually point it at my index.php file. And so again, I'm going to create another folder at the root level here. We'll call this Nginx, and I'm going to sort of try to mirror the folder structure that we saw on the server there. So inside of Nginx we had a folder called confd, so conf.d, and then inside of that folder we had a file called default.conf, and so we're going to create the same thing here, default.conf. Okay, I've figured that watching me create a server configuration file line by line would probably see my viewing figures start dropping off right about now, so I'm not going to do that. I'm going to explain one which I've just created. This is a fairly basic configuration. In production, you'd point your path towards an alternative config file which contains more error handling, etc. But I just wanted to keep to the essentials here. So Nginx is a bit different than Apache in that it can't handle PHP processing directly, so it relies on a separate PHP processor to handle PHP requests. Hence we use something called PHP FPM, which is a processor that is extensively tested to work with Nginx. Let's go through this config from top to bottom. Every key that you see in this file is known as a directive, and each directive is telling Nginx to do something, and you can nest directives inside of other directives like we've done here. Something else you can do is you can have sibling directives. So for example, I could have two different server directives here, and the server will be chosen based upon what information Nginx receives. So what these directives tell us is that this server should listen on port 80. The server name I've stuck with here is localhost, but if this was for my own site, I would change this to like garyclarke.tech or www.garyclarke.tech. You get the idea. Root is the public root folder of our application, so the request should be directed to here, and the index file is index.php. So far so good. Now these location directives use patterns, so this first one will be selective and the directives inside of it executed if the web address ends in .php. This other one will catch any other addresses, and this rule here will actually see to it that it gets redirected to where we really want our traffic to go, that being our index file in our public root. Okay, cool. So let's look at these directives inside of here. The directive that Nginx uses to define the actual server to proxy to using FPM is fastcgi pass. So basically, this is the address and port of our PHP backend. Where does this app part come from? Well, if you remember our Docker Compose file, Docker uses the names of our services as host names in much the same way that you replace the IP address for your website with the actual name of your website. It's exactly the same kind of thing. Fastcgi index, again we are telling Nginx which file to use as the index. Fastcgi params, so the primary method of passing extra information when using FPM is with parameters. So the background server should be configured to read and process these. So a fastcgi param is used to pass this extra info, and this first one here will tell our PHP backend what type of request it is receiving, so get, post, etc. And script file name is a combination of a path to the base directory, and that is set by the root directive at the top here, and appended to this will be the URI followed by the value of the fastcgi index directive. These values, which are prefixed with a $, I'm sure you've already guessed, these are variables which Nginx knows the value of. We've now got our Nginx configuration in place, but if I was to spin up Docker now, those changes wouldn't yet be recognized. In order to prove that, let's prove that. So Docker compose up, I'll do -D to do it in detached mode. That means that I'll get the terminal back. Okay, so containers up and running, and we still have welcome to Nginx and that original static HTML page. So why is that? Let's go back and consider what we've done, and it should all make sense. So if we go to our Docker Compose file, we should be able to see the answers here really. So we have our app service, our PHP, we have our web service, our Nginx, but there's nothing in this web server configuration that says look in an app folder and then inside a public folder for an index.php file as configured in our default conf. Now there is a way of copying your files and your folders into the container, and that's something that we're going to look at in the future, but at the moment we're still working on our files and our folders, and so for that reason we're going to use something called a volume mapping, and that way we are creating a mapping between the files and folders on our host system like we have here into our container. The way that we create a volume mapping is much the same way as what we did with our ports, and so I'm going to do that here. Again, this will take an array of mappings, and what we want to do is map from Nginx conf.d, and then the file is default.conf. Again, we use the colon, and then we need the location in the container. That location is etc. So etc in Linux, that's typically used as a folder which contains configuration files, and inside of there we're going to create a folder for Nginx, and then inside of there, so that our mappings are very similar, you can see the way that I've created these here, Nginx conf.d and then default conf, just makes it easy for when we go and actually do this volume mapping if things look pretty much identical. So default.conf. And then in order to find this file at this location, we're going to need to do a similar thing on our app. So here again, we're going to do volumes. So app on our host machine will map to app in the root directory of our container. Let's go and rerun Docker Compose up. Okay, so it's recreating everything and then starting everything. Let's go to the browser, refresh. Okay, and so now, as you can see in the top left hand corner here, we are seeing Hello World. I could try some other locations just to make sure that if I add some extra paths on here, we still come back to the same place. How about if I did bar.php? Okay, in that scenario I get a file not found, and that's actually correct. So you could add some extra handling in there to handle files, PHP files which are not found, in case that path mapping is matched. If I went and looked for index.php, then that path mapping does get matched, and again we see our hello world message. And so just one thing that I want to make clear here, so like I say, you can copy the files from the location into your container, and that is something that we'll do later. That's something which you'll do for production, but at the time being we're actually still working on these files, and so when we create this mapping, it means that even though our containers are up and running, I can go into this file and make some changes and they'll be reflected straight away without me having to go and restart the container. Let me just go and prove that now. So there you go, hello world, here are the changes, or here are changes. And so we can make changes and see those in real time. In order to demonstrate all four working parts, I've created this very simple app, and so what this will do is you can look for a translation. If that translation isn't already in the cache, it will add it to the cache, and so next time if you went looking for the same translation, it will get it straight from the cache instead of the database. So I think this demonstrates nicely that we can see PHP is working, the database is working, the cache is working, obviously the server is working, otherwise you wouldn't even be able to see this page. In my index.php file, I've added the template for what you've just seen. Again, this is a Docker course, it's not a HTML course, so you don't want to watch me go and write out a load of HTML and CSS. So what I've done is create this template. There's an easy way for you to obtain this, and that is to just go over to the repository. So come to garyclarke.tech, and as you can see at the moment I'm on the main branch. What I'd suggest you do if you want to get that template in that current state, what you just saw there, is to switch to a branch called front end. Each recording is associated with one of these branches. The one that I'm currently recording is called front end. If we switch to there, and then what you need to do is go into app, public, and then index.php. So obviously you can clone the entire repo, but maybe an easier way to do this if you've been coding along so far is to actually just go and click on the little raw tab here, and then you'll be able to just grab all of that content, just Command A and then copy, and then just go over to your index.php file and just paste it in there. Now that we've taken the step of adding that front end, I think it'll be easy for us to check if our system is working as a whole. In the next one, we're going to have a look at adding a MySQL database. Now let's add a database. In this one, again, we're going to use a pre-configured image in the same way that we did with Nginx. And so again, this is going to be a MySQL database, but I don't want to call my service MySQL. I'm going to name it after what it does, which is database, but I'm just going to shorten that to DB. I think that's not ambiguous. And so the way that we did this with our Nginx was we just went straight and got an image. So we're going to do that here, image. And so now we need to have a look what images are available to us. Let's go over to Docker Hub. This is the MySQL Docker official image page. Just going to scroll down and have a look. I'm on the tags tab here. Just going to scroll down looking for something fairly recent. So it looks like version 8 is the most recent version at this time of recording. And so we'll get this one here, 8.0. So that will be MySQL : then 8.0. Next I'm going to do a volume mapping again. So this will also be referred to as a mounting. And the reason I'm adding this here is just in case I'm working on something and I create some data, I don't want to come back and see that that data has gone the next time I run Docker Compose up. And so by creating this volume mapping here, it means that I have a way of preserving my development data. But the way I'm going to do this is a bit different from the last time. So here I did a mapping directly from a folder in my project. I don't want to do that. I'm going to let Docker decide where to do this and the most efficient way of doing it, because it's not files which I actually want to be part of my project and not something which I want to be adding to Git ignore. And so the way that I'm going to do this here means that I won't actually have to do that, and Docker will just take care of handling where it puts that data. It'll be optimized for my system. So I'm just going to call this MySQL data. The location for the mapping inside the container is fairly important, and that location will be var, var, then lib, lib, and then MySQL. And while I remember, I need to go and create a volumes key at the same level as where we have our services key, volumes, and then MySQL data. And if I just leave it with an empty value, then like I say, Docker will figure out the best way and the best place to put this data. But the most important thing for us to know about this is that our data will be preserved in between each time that we spin up Docker Compose. Okay, so the next one will be ports. Again, another one which we've used before. This needs to be inside of quotations, I think. And so I'm going to map mine to 3306, which is the default for MySQL. If you already have MySQL on your host machine and it's already running, then you'll need to choose a different host port. So the host port is one on the left, and so you can change it to 4306 or anything like that, just to make sure that you don't have any clashes. I do have MySQL on this machine, but it's not currently running, so I'm just going to leave mine as 3306. The next one we're going to look at is something called restart, and so this is quite common for a lot of containers. You'll want to make sure that they're up and running all the time. There is an option to say always, but I tend not to use this in my development environment because it sort of becomes like a hydra and I can never kill the container. I think a best strategy for development is to use this one here, unless stopped. So this means that it'll restart, so if anything goes wrong it'll just restart unless stopped physically by ourselves. So I think this is a good setting for us, we'll stick with that. Next we need to pass some information to MySQL, such as the user, the password and the database, and we can do that using environment variables, and we add those using the environment key. This is something that we're going to touch on a little bit more when we go and add some environment variables to our Dockerfile, but basically we declare some environment variables, give them some values, these will be passed into the container, and MySQL is smart enough to know to be able to read those environment variables to configure things the way it needs to. I'll not make you watch me type them all, these are the ones that you're going to need to have. You need to spell these exact because this is exactly what MySQL is looking for. So MySQL root password, MySQL user, MySQL password and MySQL database. They are the basic ones which you will need in order for this to work. You don't have to use the same values I've used, use your own. If you want to know a bit more about these variables and what they do, again come back to the MySQL page on Docker Hub. Click the overview tab and then about halfway down the page you'll see this environment variables, and it has a description of what they all do and how they are used by MySQL. And that completes our setup, so I'm good to go and run Docker Compose up again. Docker Compose up -d. And so the first time that you run this, what will happen is the same thing as when you went and got your previous images from Docker Hub. So when it went and pulled the Nginx image, it will go and pull you a MySQL 8 image as well. I've already got it on my machine. I have a MySQL 8 image because obviously I have a little practice run through before I record these things. I want to test that connection and go and add some dummy data, so I've opened up my database client. I use Table Plus, not an endorsement, I just find it really easy to use. I've entered my credentials and the details, so the ones that you need are these: host 127.0.0.1, so local host, port 3306, the user is the username, which I use the environment variable here, MySQL user, and the password is what I used here, secret, and the database is what I used here, Docker PHP. So user, password, database. Those are the 5 pieces of information that I need. I've tested the connection. Table Plus is telling me that that works, and so I shall connect. I want to add some tables and some dummy data which I can use here. So the functionality in Table Plus, I can import this, import from SQL dump. If you don't have this functionality on whatever tool that you use, then you can just copy and paste the commands, and I'll leave the SQL files as part of the repository in a folder called SQL. So inside of Docker PHP, you'll see them inside a folder called SQL, and the file is simply called docker-php SQL. So I'll click that and I'll import that. Okay, Table Plus is telling me that's been successful. Refresh, and so you should see 2 tables. One with languages, very simple table, just 2 columns, and the other one is translation with some basic translations from English to the target language. So I kept things nice and simple. Like I say, this isn't about building an application, it's about how you actually piece it all together using Docker. And here is that file inside of the project, so inside of SQL, docker-php SQL, and then you can just copy and paste the commands to build up those tables and add some data. The next thing we're going to take care of is Composer, for a couple of reasons really. We're going to need it for the auto loading, so in order to create any more of our application we're going to need it, and also further down the line we're going to add Redis and use that as part of our querying. So let's go ahead and add Composer now. It's going to be a number of steps which will include adding Composer to our PHP image, copying our Composer JSON file into there, and then installing all of our dependencies, adding our working files, and then finally running Composer dump autoload, and then autoloading will be working for us. As you can see, my Docker file has become quite a mess with a lot of the comments here, but these are some of the best resources which I found currently on the web which explain some of the decisions I made about how I'm going to create this file. So I'll talk you through these one by one, and I'll also leave these comments on this file, which is a step that I don't normally do, but when I push this to GitHub, it means that you can go and check out these resources yourself and do a bit of your own research should you want to do that. Okay, so the first thing we want to do is allow super user. So we are going to set this because we are going to use Composer as a super user all times, which is what you do inside a Docker container. And the way we're going to do this is with an environment variable. The way we specify an environment variable in a Docker Compose file is with this env, and the environment variable is Composer allow super user, and then we're setting it to 1 to mean true. Now we want to obtain Composer, and we actually want it inside our image, inside of our container, not inside its own container. And so how can we do that? Well, we can do it by actually going and getting a Composer image and copying it into our own. And we can do this like so. So the command for this is copy. We are copying from the Composer 2.4 image, and the parts that we are copying are this user bin Composer into the same location in our own image. And so if you want to know more about what we've done there, you can check out this article here, this Docker page on multi-stage builds. Multi-stage builds is actually something which we are going to touch on later on when we go and add XDebug to this. So all will be covered and explained in detail. Moving on, what I want to do now is copy my Composer JSON and my Composer lock files. And the reason I'm doing this is to take advantage of the Docker cache, because when Docker sees that something has changed, then it will rebuild the entire image from that step onwards. So if things haven't changed, if things are the same as the last time you ran build, then it will just grab the parts from the cache. And so like you see here, this is enough to take advantage of Docker cache, and Composer install will be executed only when Composer JSON or Composer lock have changed. So if those things haven't changed, we're not building new stuff, we're just grabbing things from the cache. And so again, we are copying from app Composer, And so we're using a wildcard, so this can mean composer JSON or composer lock, and they will be copied into this location inside of our container. The next command is our install command. So this is just your typical composer install. We're not installing our dev dependencies because we will use those locally, and I'll show a way how we can do that. The rest of these options may or may not be familiar to you. Just check out the Composer docs if you need to look anything up. This one here, no interaction, is quite important because we just want the install to go smoothly without a user being prompted for any interaction, and so that's what that one does. Our next step is to copy our application files to the working directory. So the working directory is the default directory which will be used for our container. And what you'll find is they'll typically come with a default. You can actually change that. If I was to say work dir, and then I could change this to whatever I wanted, like so. I'm not going to do that. I'm actually going to go and see what the default working directory is, and I'll probably end up using that. And so I can find out my working directory by running this command here. So docker exec, the IT option means give me like an interactive terminal, and the sh after the container name means shell. So it's like I'm shelling into the container, and then the location which you see when you initially do that, that is actually your default working directory. So I think we'll stick with that. We'll come out of there, and just while I remember, we'll go back to the docker compose file. And so I've been sort of using this as the working directory. Might as well change this while we're here. Var. Okay, good. So this means that now we're going to be mounting from this directory into this one inside of the container. I'll also need to make this change to my default.conf file for my Nginx. I'll do that shortly, but if you want to go ahead and do that now, then that's totally fine. Let's go and see what we've got left to do. The final act is to run composer dump autoload. And so those are the basic steps that you need in order to add composer to your container and to install your dependencies. Let's now go and add a composer JSON file. So inside of app, behind the scenes, I'll just add some values here. Okay, so it's a fairly basic composer JSON file. You've got the author details, etc., and repo details at the top. In the require section, so we're saying that this project requires at least PHP 8, PDO extension, PDO MySQL extension, and then these parts are going to be important later on. We're asking for Symfony Cache and a package called Redis, which is used for working with PHP and Redis. Dev requirements, we're going to ask for PHP unit, and we'll add some tests to this, or just a basic test as like a demo thing later on. Auto loading, and so we're making a mapping between the app namespace and a folder called src. So I might as well go and create that now while I remember. And scripts, I've just added one simple little script to the bottom, so we can just say composer run PHP unit, and it will run this command. Before I run this, I will actually need to make sure that my root matches what I've just changed this to, my docker compose file. Okay, so let's actually go and try to build this. I'm going to say docker compose down first of all. Okay, and then I'm going to say docker compose up -- build. So that means it will look at my Docker files and build images for me. And then again, it will say -d, which means run it in detached mode. So I'll get the terminal handed back to me. Okay, let's go. So you can see some of the new stages there. As you can see, it's copying composer, running composer install. And now it's starting up my containers. So you can see that top one is actually the network, so the network of containers, and then we have the actual services, containers which we created for our database, for the server, and for our application. Let's have a little scroll up and see if we can see all of those stages of the build happening. And so we've got stage 1, which is getting the PHP image. 2, we are adding our extensions. 3 is where we are getting composer. 4, we are copying our composer JSON file and our composer lock file. 5, this is where we run the installation, and then we are copying the contents of our app directory into the working directory, and then we just run composer dump autoload. Then the final stages are which Docker takes care of for us. It gives the image its own unique hash and then names it for us. Okay, so here we are. So far, so good. However, there is a problem with this, and I'll show you that now. If I go and look inside of my container again, and I list everything in here in the working directory, if I've run composer install, then I really should be able to see a vendor directory here, but I don't see a vendor directory here. And so why is that? This means that I don't have any of my dependencies which I thought I'd installed. Well, they were installed. However, when I go and do a volume mounting like I'm doing here, basically this overwrites anything which is already in here. And so even though I did install to this location, actually it's this folder which is being mirrored into this location. And so there are a couple of ways which we can get around this. I'll show you both of them. The first one is to do this. By just saying var www html vendor, if I specify just the one location, basically I am saying protect this location inside the container. Don't overwrite it. Whatever gets put into there when this container is built, make sure it gets preserved, regardless of whether I do any other volume mountings. So if I go and run Docker Compose up again, I think I can do it without build. And we'll go inside the container again, list everything. Okay, so this time we now see that our vendor folder is in there. Basically, we've preserved this location so that it can't be overwritten. And so yes, that's one way of doing it. That's perfectly valid. However, I'm going to think about doing this a different way, because my two different use cases between development and production are starting to diverge a little here. This is something which I'd only really need to do in development, because in production I'm just going to copy the files. They'll get copied into the container and they won't need to be touched again. Once they're in the container in production, then the files are there. Whereas here, I'm actually still currently working on them. And that's the main reason why I have this mapping. So if I go and make a change to a file, then it'll be straight away reflected without having to build anything again. There's other things which I'd like to change. So this build stage here where I'm actually building from a Docker file in production, I don't want to do that. What I want is a similar thing to this to happen. It just goes and pulls an image, creates a container from that. So the executive decision I'm going to make on this is to have two Docker Compose files. I'm going to keep this one for production, and then I'm going to have one which I'll use for my development environment. I'll just give it a different name like Docker Compose.local or something along those lines, and then I'll be able to do what I want in that one, create my development environment exactly how I want it, but then I'll still have this preserved Docker Compose file for my production environment. Let's work on that one next. I shall start by copying this file, so copy that, paste it, and I'm going to call it docker compose.dev.yaml. You might see docker compose.local or whatever. It depends on your team's naming conventions, but this is what I'm going to use here. Initially here we're going to consider having separate files for dev and production, i.e. you use one file in dev and one file in production, but later we're going to have a look at overrides, which I think is better, and that's where you can use multiple files, and it involves creating a hierarchy where the config in one Docker Compose file can override that in another. Okay, so this is that dev file. What I'm going to do is go through both of the files, the dev file and the production file, and just add or remove what I actually need. So for the Docker Compose dev file, I'm going to keep it more or less the same. The only thing I want to do is remove this, because we're not going to pin this vendor file anymore. We do want to mount our app folder to this location inside the container. Just scrolling through, I think all the rest of this is perfectly fine, because we've sort of been working on a development configuration up until now. Our production file will contain some edits, So working down here, this is okay. Ports, we still want to expose the ports on production, otherwise there'd be no way into our application. But we don't need to expose the ports for the database because we were just using that so that we could use like a client and go in there and have a look at things. So we'll remove that. These environment variables, obviously we're not going to hard code these, so I'll create a .env file maybe in a later recording. Restart unless stopped. So in production I'd probably change this to restart always, but I still want to be able to run this file for the time being on my local machine. So what I'm going to do is I'm just going to leave that as one of the last things that we change, like towards the end of the whole recording. Okay, I'm happy with the database volumes. This needs to change. In fact, we don't need any of these because what we're going to do is copy the files into the container. In fact, that's what we did when we worked on the Dockerfile in the last recording. So what we can do is just remove that completely, because the main reason we have this is so that when we make changes inside of this folder, it immediately gets reflected in here. But we're not going to need that in production. Let's get rid of that. Another change I'm going to make is I'm going to do a similar thing here actually. I'm going to, instead of doing this volume mounting here, I'm going to do what we did with our PHP Dockerfile, and I'm going to copy the files from there into the container. So let's go and do that now. Inside of our Nginx folder, we'll create a Dockerfile for this. And so from will be Nginx, and we'll say latest. One thing I will say on using latest, I've never had this problem with Nginx, but I have had it with other things such as Node, which can be a bit more flaky, and the image hasn't been compatible with like other services that I've been using. So if you do get that kind of problem, then maybe you want to specify a particular image from Nginx. So check out that option if you do get problems. The next thing I want to do is actually copy these. So I'll just copy that so I've got a reference. I'll just add it as a comment. So I am copying from that location in this project, then you leave a space and then you're copying to there inside of the container. One other copy to do. So that we have that entry point into this, we need to copy our public directory where our index.php file is to a location inside the container. And so that will be app public, and that will be to here. Okay, so just a reminder of that location. If we look at our default conf, that is the location that we specified as our root. Okay, I can delete this now. I'll go back to the Docker Compose, our production Docker Compose. And so here we're not going to ask for an image because that image is being pulled in the Dockerfile which we just created. In fact, what we're going to do is we're going to say build, and then we need to specify the Dockerfile to build from. That is in Nginx Dockerfile, and I think this should be okay. Just one last check. That all looks good to me. One thing I will say about this is that later on I'm still probably going to change it even further. Instead of doing the build, what I'm going to do is I'm going to build the image and push them up to the registry, and then here again we'll go back to saying image, but instead we won't be using the image from Docker or the official Nginx image. We'll be using the image which we are building with our Dockerfile there. And so that means that you're saving a load of building as part of the deployment process, because the image will have already been pre-built and it'll be just pulling in that image and then creating the container from it. Okay, I now want to try both of these builds, so I'll try this production one first. Docker compose, say up -- build -d. Let's go. That's built. Let's go and check localhost. Okay, everything is working there. Just want to show you something now. So if I go to app public index, and then at the top if I do echo world, or should I say echo hello world, when I go back to the browser and refresh, we don't actually see it. And the reason that we don't actually see that is because we are not doing that volume mounting from our app folder anymore. So we've copied the files directly straight from that app folder into our container, and that is the end of it. So the container is just going to use what files were copied into there. With our dev setup, on the other hand, we should be able to do that because we are doing the mounting. If we go back to our docker compose.dev file, here's our volume mounting, so any changes that we do make in this app folder will be reflected. So let's go and run these down, and then we'll run up our dev environment. So docker compose down. Okay, so how do we build up our network using this docker compose dev file? So by default, docker compose, the command will look for a file called docker-compose.yaml, but you can specify a different docker compose file, and that's what we need to do here. So I'm going to say docker compose, then it's -f for file, and so here we just need our alternative, our dev file, docker-compose.dev.yaml up -build -d. Let's check this in the browser. Okay, so as we can see, the hello world, but we actually put that in there before we built the container. So let's go over and change this. In fact, all we need to do is just remove it. And then if we go back to the browser, refresh, as you can see, it has gone. Put it back in there, just change it to something else just to be doubly sure. Hello world again, refresh. So as you can see, our changes are being reflected straight away. We're now going to have a look at environment variables. Now we can use them inside our containers. Before we do that, what I want to do is install my dependencies locally. If we look at our PHP Dockerfile, as you can see here, when we run composer install, we're actually not installing our dev dependencies, but I want my dev dependencies locally. If I want to add like Symfony var dumper, or if I want to add PHP unit, which are normally things which you add as dev dependencies, then I won't actually have access to them with the current setup. But let's remind ourselves how we've set this up in our Docker Compose file. If I do install my dependencies inside my app folder, then that will then be mounted into the var www.html folder. So that means that I can work with my dev dependencies also. I'm going to cd into my app folder, and then I'm going to run composer install, and I'm going to say ignore platform requirements. The reason why I'm going to do that, let's go to the composer JSON file, is I have specified PHP 8 or PHP 8 minimum. If we go and look at our Docker file, we are saying at the top that we're using PHP 8.1. So if I'm not actually using that version of PHP on my local machine, I might have problems when I come to install this. But if I say ignore platform requirements, then it'll ignore which version of PHP is on my computer, and it'll just go ahead with the install and install the versions which we have asked for in our composer JSON. Hope that was clear. Let's go back and install this. So the option I want is ignore platform requirements. Okay, everything's installed there. Just a quick reminder of what we've installed. We've asked for, as a dev requirement, I've asked for PHP unit, and for our actual installed normal requirements, we're getting Symfony cache and Redis, which we're going to use shortly. Next thing I'm going to do is run composer dump autoload. That will generate the auto-loading files, which means that auto-loading will work for me. And then we shall spin everything up and we'll shell into the container, and I'll show you that those dev dependencies are in there. So docker compose f docker compose dev.yaml up -d. That's all good. In fact, I need to go up one level because when I ran composer install, I cd'd into the app folder because that is the folder which contains our PHP application files. Let's go up one level and we'll try that again. And in fact, while we are on the subject of folders and context, I'll just have a quick run through everything for you, because sometimes you might see in a Docker Compose file, you'll see build and then you'll see context. I've not supplied a context, so that means that it will use the folder which this Docker Compose file is in as context. And so when it goes to build this Docker file, let's go and have a look at this. It is actually using that folder where the Docker Compose file is as the context. And so it means that when I'm specifying my paths, I'm specifying them from that location, i.e. the very root of this project. And the reason I did this is because it keeps life simple. Say I wanted to access a file or folder which was sat in a parent folder to this Docker file. You can't actually do stuff like this where you are going up one level, and so I find it's best to just take that top-down approach, do everything from the context of the root, and then you won't have those kind of problems or those kind of problems to solve. Okay, with that out of the way, let's get back to the task in hand. I want to look inside this container and just check that my dev dependencies are inside that vendor folder, or prove to you that those dev dependencies are indeed inside that vendor folder. So we shall cd into vendor, and we just need to see if there's a PHP unit there, because that's the only dev dependency we have at the moment. And as you can see, PHP unit is there. And so if we weren't using that volume mounting, if we were just dealing with what had been copied over into the container, then we wouldn't have PHP unit. No dev means don't install the dev dependencies, so that means that we wouldn't have had PHP unit when this was copied over into the container. Anyway, let's come out of there, and what I'm going to do now is I'm going to add some source files. So before I do that, actually I should have done this already, I need to create a branch for this particular recording. So things are nice and clear. I'll be able to push it up to GitHub, and you'll be able to go and grab the branch for this particular lesson and just add these source files that I'm about to add. So I'll actually go and create that branch now, git checkout B, and I'll just call this environment variable, so this will be the branch that you need to look for. Okay, so that's pushed up behind the scenes. I'm just going to go and add some source files now, and then I'll talk you through them. Okay, so inside of app, we have this folder called source src, and so inside of there I've just put some application files, and they're all related to connecting to the database and querying the database. The main file that we are concerned with in this one, where we're going to look at the environment variables, is one inside of database, and it's called connection. And so if we scroll down to the constructor, there are basically 5 environment variables in here, and they're all they're all related to connecting to a database. So we have MySQL host, MySQL database, MySQL port, MySQL user, and MySQL password. And so in order to get these environment variables into here, we can use our Docker Compose file. So let's think about this. We want to access those environment variables inside of our application code. What is the service which is responsible for handling the application code? Well, it's actually this app service here, and so this will be where we define those environment variables, even though we've already defined them here, but this is in order to tell MySQL what those values are, but now we actually need to tell our application what those values are in order to make that connection. I'm not going to make you watch me write these line by line, we'll drop them in here. Okay, so for the time being I've just hard-coded these values in here like so, but in a moment I'm going to show you how we can actually pass environment variables into our Docker Compose file in order to set environment variables. Let's go and rerun this, because Docker Compose needs to know about those changes. And so you'll have seen there something quite interesting. It didn't touch these first two because that was the database and that was web, i.e. our server. So it just left those running, but the changes had been made to the app service. And so as you can see, that got restarted. And so I've got my records in my database now. I now have my application connected to that database. Hopefully I should be able to use this for real. So we'll select a language and we'll go and type in hello, if I can spell it correctly, hello, translate. Okay, and so that is actually coming from the database. Let's try and translate one which isn't actually in the database. So again, if I try and translate one which I know is not there, so it says translation not found. The code for all of that, by the way, is just in the top of the index.php file. We're just going into the translation repository, and inside of there's a query which looks for a translation of a particular phrase. So have a look through that in your own time. Like I said earlier, this course isn't about stuff like this, database queries or PHP code. It's about getting a Docker system up and running. So I've tried to keep it as simple but as fairly realistic as I can get away with it. Now, like I say, I've just hard coded these in here, but I can actually pass environment variables in to set my environment variables inside of in fact, it will be at the very root of this project because that's where the Docker Compose file is sitting. So here, if I just create a .env file, I can set my environment variables inside of this, and in order to access these, then inside of my Docker Compose file, I just do this kind of thing. So you can do them with the curly braces or without. If you're actually injecting them inside of a string, then you'll need to do it this way, but I could do it by just saying this. Either will work. I'm just going to use the curly braces so that we have consistency in case I do want to inject it inside of strings later on. One thing I should cover here, notice the MySQL host. Where is this DB coming from? Well, the MySQL host is the actual, we use a service name, like I said before. It sort of uses service names like IP addresses. So we said that our database was this, and so that is what we use for the database host. And by the way, when you use a Docker Compose file, all of these things, these services inside of here can automatically find each other. So if I say I'm looking for web in part of my environment here, then it will automatically be found. You don't need to add any extra configuration. Basically, every service which you define underneath the services key is capable of finding any other service which you define underneath this services key. They all by default get added to the same network. Now you can specify your own networks inside of here. I've not needed to do that because all of these services, I just want them all to belong to the same network, and so I'm just going to use the default one, and Docker will automatically give it a default name. Okay, let's carry on adding these. Just to keep life simple, you'll notice that I've used exactly the same names here as what I'm going to use here. Okay, again, after any changes which you make to your Docker Compose file, you need to go and rerun this again. And you'll see that Docker was actually smart enough to know that no values have actually changed there, so this should still be working. Let's go over to our browser and prove that theory. Okay, perfect, and so we still have a working application. One other thing which I will mention is that you can have different .env files for different environments. So say for example I wanted to have one which was like the default for production that I called .env, no problem, but then I might want to go and add one which I'm just using locally or using for development, in which case you can just add an extra option to your command. I'll just make this a little bit smaller, where you will say .env file, and then you specify the file which you want to use as your .env file. Or should I say the path to your alternative .env file. And another thing that I'll mention is that with a lot of cloud computing solutions, you won't actually need a .env file. You'll just go and enter your environment variables using like a user interface. Anyway, that covers environment variables. Let's move on. And so here are those source files. I'm on garyclarke.tech-php. Inside of the source folder here, you'll find all of them. So the one that we looked at was the connection one, and so you can do this one of two ways. You can either pull in the repo or pull in the branch, or you can actually just click on it, and then if you go to raw, then all you would need to do is just grab all the code, copy it, and then just go and paste it into a file. So yeah, that's where all the stuff is, and the branch for this recording is environment variables. So Redis is an in-memory data storage, something which I've been used pretty much since it first came out. Really flexible, good for all kinds of things. You can use it as just a plain key value store. You can use it for queuing, message broker kind of stuff. We're going to use it for caching, and the way we're going to use it is when we go to put new things to translate into the database, we're also going to add them to the cache so that next time that we go looking up the same translation, we can grab it from memory, from the cache, instead of hitting the database. So it should make our application a little bit faster. The way we're going to add it is by adding it to our Docker Compose like all the other services, and again following the same rule. We're not going to call this Redis, we're not naming this after the technology, we're naming it after the function which it performs, and so we're going to say cache. Good news about Redis is for what we need, the setup, the configuration here is really straightforward. We're going to say image, the image is of course Redis, and we'll just go with latest, and I think latest will be fine because the functionality that we're going to use it for here, that will never change, and so I can't see this breaking at any point in the future, so I'm pretty sure that latest will be fine. The next thing I'm going to do is run Docker Compose, and so as you will probably have seen there, it went and actually grabbed Redis from the registry because we didn't have an image for that yet. What I want to show you now is the port for Redis, because we're going to use this as an environment variable. So if we do docker ps, ps stands for processes, by the way, so you're looking at which Docker processes are running. If we hit that, I'll just make this a little bit smaller. Okay, so you should be able to see Redis here. Hopefully you can pick that out, Redis latest, and then when we see ports 6379, so that is the port which Redis will use by default. And so instead of setting our own port, we're just going to use the default port there. So we'll go and add that as an environment variable because we're going to need this in our application. So we'll move up to here. Redis host will be cache. So Redis host, and then we're just again using the name of the service as the actual host address. And then Redis port. And for this we'll use an environment variable like the others, so let's go and find our .env file. And then once we've added this, of course, we'll need to go and run Docker Compose up again because we've made changes to our Docker Compose file. So let's go and run that command now. And then the next thing I'm going to do is I'm going to go and make some changes to my source code because we want to add some caching in here. Behind the scenes I've made those changes, so inside of the source folder now I've created a special translation cache, and so what this will do is it will look in the cache first in order to see if the thing that we're trying to translate is in the cache. If it is, it will return it from the cache. If not, it will then carry on and query the database. And so the first time that we run this, the first time that we look up a certain phrase, I'm just going to echo out this adding phrase to cache, and this is really just to prove to ourselves that our cache is being used and is being hit in the right circumstances. So really just a little development debugging thing there really. The other change that I've made is obviously in order to use the cache, in order to use Redis as a cache, we need to add some configuration. So I've made some changes to the PHP code, which sits at the top of the index.php. The branch for this one, by the way, is called add Redis, and so if you want to have the same code as what you're seeing here, then that is a branch that you need to go and get. Okay, and so as you can see, we create the client. So this is the Redis client, and then we pass that into a special adapter. So these are like Symfony classes, Symfony components, part of the cache component suite, and we have a Redis adapter. We pass our Redis client into that as the lone constructor argument, and then we have this cache adapter, and then we can use that in order to retrieve items from the cache, store items in the cache. It's all going to be pretty cool. The most important parts that you see here are the environment variables. So these are what we've just set up in our Docker Compose file. We set up a Redis host and a Redis port. Okay, and so this is our application code. It was the app service which is responsible for this, which is where this is housed, and so we're able to access those environment variables within here. The final thing we need to do is make sure that this is working the way that we expect it. So let's go and translate a phrase. So the first time that I run this, I know that this is not in the cache, so I'm expecting to see that echoed message at the top here. Let's run this. Okay, so it's now adding hello to cache because it's the first time I've run it. That is now inside the cache, and so the next time that we run this, it won't actually hit that part of the code. It will just go and get the item from the cache, I hope. So let's run this again. Hello. Okay, perfect. We don't see the message. That means that it's been and got the item from the cache, which means that all the code which we have just written works. We're now going to add a development and debugging tool called XDebug, which I'm going to show you how to use as a step debugger, but it can also be used as a profiler and various other things. What I will say about this part of the tutorial is if anything's going to go wrong, then it's going to be in this section. However, my tips for overcoming any problems is first grab my code from the repository, try it with that, and in most scenarios I think that will fix it. If you're still struggling, then just post a message in the comments, explain what operating system you're using and what versions of everything, and then we can take it from there. This place that we're going to start is in our PHP Dockerfile, where we're going to make some changes, but also we're going to add some new stuff, and I'm going to talk to you about something called multi-stage builds. Now, I'm not going to make you watch me type all the stuff that we're going to do here. What I'm going to do is I'm actually just going to drop each line in and then explain them and add comments as we go. So from top to bottom, here we go. The first one I'm going to add is a really cool image, and it's a PHP extension installer, and so this will really help us because XDebug requires a load of other extensions and a load of other software to be installed in order to install XDebug. However, with this PHP extension installer, that stuff is all taken care of behind the scenes, and we can just run a very simple command. And so what I'm going to do, and the reason I've dropped it in right at the top here, is I'm just going to replace what I've already been using to install extensions with the new thing that we're going to use here. And so what I'll actually do is I'll comment out the old command so you've still got that reference, but the new command is going to be this. And so the first thing that we're going to do here is just set this functionality, which, as you can see from the comments, it's quite a common Linux command that you'll see this, but it basically means exit on errors, exit on any unset variables, and print every command as it is executed. And then we are using our new command for installing PHP extensions. Install PHP extensions, and then this part, as you can see, is still the same as what we were doing. We're installing the PDO MySQL extension. Hopefully all that makes sense and should be fairly easy to follow. The next thing we're going to consider is multi-stage builds. They're not that difficult to understand, but they're not that easy to explain. What we're doing here is we're pulling the base image, and then each command is just adding an extra layer onto the one build. However, we can take our build here, give it an alias. So if I say from image as app, I can now make a reference to this and start another build on top of that. I hope that makes sense. So I now have an app image from which I can build upon. So I can now say from app as, and then I can give this whatever name I want or whatever alias I want. And so I'll call this app dev, because what I'm building here, I just want to use this for development purposes. And there are commands which I can run, and I'll show you them shortly, where I can just target this build. I can say I want to target app dev, which means it will build everything. So then it will build app, and then I will build on top of that with app dev. Sorry if that sounds like a really messy explanation, but it's the best way I can think of doing it. And so that makes it optional. For example, if I didn't want this stage of the build, then I can run a command where I'm saying just build me this part. And so we can have that for production where we don't want to build and add our dev dependencies like XDebug, and then we can have this further build where we say okay, build this, and then we can add XDebug, and that's exactly what we're going to do. And I'm going to drop some resources on top of there. Just a couple of links you can go and look up multi-stage builds, and you can go up and look at targeting certain sections of builds. Okay, let's make a little bit of space for ourselves here. So like I say, XDebug has different functionalities. You can use it as a profiler, you can use it as a step debugger, or you can just set it to off because it can be quite process heavy and quite intrusive. And so as a default, we are going to actually set the debug mode to off, and then we'll be able to just pass in an environment variable. So have we covered environment variables? Yes, we did it earlier here where we set composer allow super user. And we can pass that environment variables in like this way. So we're giving it a default value of off. However, when we go to run the command to spin up this container, we can set it to whatever, and we're going to be setting it to debug for our debugging needs. The next thing we're going to need is some special PHP configuration in order for XDebug to work. So we're going to have to go and create an INI file which has some settings inside of there. We've not created it yet, but this is the path that we're going to use. So this is going to be confd in our PHP folder here, and we're going to call the file xdebug.ini, and this is going to be the location where that needs to be copied to in our container. So we're going to take care of this file in a moment, but we'll finish off this file first. Our final step is to install XDebug, and so we're using our new installer here for PHP extensions. What I can tell you is that if we weren't using this command would be a lot longer and a lot more prone to errors, and this is really good. It takes care of everything for us without us having to worry about having all the right software and things installed in order to install XDebug. It's a real lifesaver actually. Next we need to create our xdebug.ini file inside of this location. So inside of PHP we'll create a folder called confd, and then in there we're going to create a file called xdebug.ini. And then behind the scenes, I'm just going to drop in the information that we need. Okay, so this looks like quite a lot of information for what is essentially just one setting. So this is basically the information that is important to us. The host has a changing IP address, so your host computer, or none if you have no network access. So it's saying we recommend that you connect to a special DNS name host docker internal, which resolves to the internal IP address used by the host. So your IP address used by the host can be quite fluid, it can be changing, and so by using this it means that internally Docker will know where to connect to that host. And then just bringing your attention to this line at the bottom, it's for development purposes only. This won't work in a production environment outside of Docker Desktop. So you won't have Docker Desktop in a production environment anyway. The links at the top, they just link to information on pretty much the same thing. In fact, this spiel I got here, I think I got it from this link anyway. Feel free to check it out if you want more information on that stuff. Okay, we are now on the final stages. We need to go to our Docker Compose file, and we're going to add some new entries to our app service. And the first one is regarding our build. So if you remember what I was saying about multi-stage builds and targeting different stages, so for development I'm going to say yes, I would like to actually build this stage here, app dev. And so in this file I would say, yeah, I want to target this stage here. And so underneath where it says Dockerfile, I'm going to say app dev. For my production build, if we go to our other Docker Compose file, what I would do here is actually say target app, and then it would only build as far as here. And so again, just to reiterate what will happen with the dev build, it will build this stage, which is all of this, and then it will take that and build on top of it with app dev. And the reason we're doing it this way, if it's not already obvious, is that we don't want to be dropping debugging tools into production. It's only something which you want locally for your development. Okay, next I'm going to add a new volume mounting, and this will be for our xdebug.ini, and then on the end of this I'm just going to append this here, RO, and RO means read only because this is not something that we want to be writing to in our container. We've set our configuration, we're happy with it, so we're just going to leave it as read only. Next, under environment variables, I'm going to add a new one, and this is going to be the same as what we put in our Dockerfile, and this is XDebug mode. And so this funny syntax that you see here, what we're saying is if we don't have an XDebug mode environment variable being passed in, then default to off. So it's a colon, a hyphen, and then the default value that you want. So XDebug mode will always default to off, and it's going to be when we actually run the docker compose up command that we will set this XDebug mode environment variable. You can do it in a .env file, that's an option, but I'm going to show you how we can do it from the command line as well. This final one will be extra hosts. So if you recall what we said about host docker internal in our xdebug.ini file, this setting here that we're using basically is so that this will work with Linux. And so if you are using Linux, then you need to add this extra host here in order for this to be defined for Linux. Okay, that's been quite a lot of work, but I think we're ready to spin this up. What I will say is just make sure that your files look exactly the same as mine, because if you get any parts of this wrong, then it definitely won't work. This is the most fiddliest part. Okay, so the command that we need to run, docker compose -f, we're telling it to use our dev file because in there we have specified that we are using app dev as our target for the build, so that's very important. And we've made changes to our Docker file, so here I'm saying build, and hopefully this will work. And so what you will find is that the XDebug installation stage will take a while because there is quite a lot of it to install. But don't worry, just watch it do its thing. If, like I say, if you followed all the steps that I have used, then it should install eventually. Let's go and try this out. So if you've ever used PHP info, we're going to use one called XDebug info. So in app public index.php, right at the very top, just underneath our opening PHP tag, just drop this in there, XDebug info. And then you just need to visit localhost :80, and hopefully you should see this. So this is your XDebug configuration. Quick scroll down, you might see some of the things that we've looked at. Here is the XDebug mode environment variable that we were talking about. If you remember, we set it to off, which means that all of these things are disabled. However, in a moment we're going to enable step debugger, so we can set XDebug mode equals debug, and then hopefully we should see that that is enabled. Let's see if there's any other things which we might have looked at. So additional INI files passed. As you can see, there's our XDebug INI file which we created. Again, XDebug mode currently off. XDebug client host, so again that's one that we set, host docker internal, and by default in, I think this is version 3 of XDebug, it uses port 9003 by default. Anyway, I'll let you go through all this in your own time. It'd be a pretty boring tutorial if I went through every piece of configuration in an XDebug file. What I'm going to do this time is I'm going to run docker compose up again, but this time I'm going to pass in an environment variable. I can do that from the command line by setting that before I run the command. So xdebug mode equals, and what you want is debug, lowercase debug, and I don't think I need build this time. So xdebug mode equals debug, and then the same command, docker compose -f for file, docker compose.dev.yaml up -d. Let's try this again. And so as you can see, the only change there was the docker PHP app. So can you think why that might be? It's basically because that's the only thing that has changed. And what has changed? The environment variable. So xdebug mode is now debug. So this is looking quite promising. Let's go back and run or refresh our browser. Okay, perfect. So ignore this error. I'm getting this because I have like a Google Chrome extension. I've got my little XDebug thing enabled there. I'll talk about that in a moment. So I'll turn that off. But the thing that we are looking at, and the thing which is currently making me happy, is that XDebug or step debugger is now enabled. So hopefully we should now be able to go and start using that and stepping through our code. For actually running XDebug, I have this nice simple setup where I use this Chrome extension called XDebug Helper, and I can just enable this little bug here as well as enabling this little telephone thing here, and then when I run the request, it'll just first come up with like a pop-up which will say, do you want to accept this request, and it'll show me some configuration such as the host, etc., and then it's up and running. If you're not using that, and whatever IDE you might be using, the configuration might be a little bit more involved, but do a bit of research on it, you'll soon find the information that you need. Let me talk you through how it's going to work for me, or let me give you a demonstration of how this works for me. So first off, in index.php, I'll remove this because I don't need it now. And then what I'm going to do is I'm going to put in something called a breakpoint here. So this isn't actually an XDebug lesson, by the way. This is a tutorial on installing XDebug in Docker for development purposes. But it wouldn't be a complete tutorial if I didn't actually show you it working. So I put in something called a little breakpoint or a breakpoint, and then I go and enable my bug here, debug. The other stage that I need to do is I just click on this little telephone, so it's now listening for debug connections, as you can see from the little tooltip thing there. And that means that I can just go and hit refresh or hit enter on this, and then automatically PHP Storm will come up with this. It says it's got an incoming connection from XDebug, server name is localhost, so that's what we actually defined in our default.conf Nginx configuration. Server port is 80, that is correct. File path on server is this, and that is correct. So I'm going to accept that. And so now we are actually at this stage. It has stopped here, and I can inspect all the different variables which are set. And so the only one which is set so far is this one, client, and as you can see I have that variable, and so I can go into it and just see what things are set. I'll find a more easier one. So if we look at things like translations, we should be able to get something back from that. So if I click this, then it will step into the next part of the code, and you just keep stepping through. As you can see, it shows you all the different values which are currently set for different variables. Let's go to the next one. Okay, and then once I step over languages, it means I now have the languages variable there. So I've only got three languages in my database. Let's go and inspect these. And so as you can see, the first one is an instance of language because I created a language model, and it has an ID of 1 and a name of French. And so I've also got inside of there one with an ID of 2 and a name of German. I'm sure you get the idea. So as you can see, nice, pretty powerful tool here. You can do quite a lot with XDebug. Really good if you're working on a code base that you're not familiar with. You can just go stepping through the code, seeing which variables are set, seeing how things are getting set, etc. But like I say, this is not an XDebug tutorial. If you did get to the stage where you were able to print out XDebug info and debug was enabled, then I'd say well done. You've got all the hard work out of the way. And then if you want to use this tool, then just go and find some videos on YouTube on how to use it for your IDE. You'll soon find the information that you need. In this one, we're just going to continue to have a look at multi-stage builds because I'm conscious of the fact that we've seen the full build of our Dockerfile. So we built the whole lot because we targeted app dev in our Docker Compose file here. So what I want to do is actually change this target to app, and then you'll see that the rest of the image does not get built from this stage onwards. So first off, let's just go and check what we've got so far. We've targeted the app dev stage, which means that we should have XDebug. So if I go to my index.php, and at the top here I'll just drop in a PHP info, And then if we go back to our browser and refresh, then when I do a search for XDebug, as you can see, we've got 138 instances of the word XDebug, which means really that it is installed. And so if we scroll down, if we keep going down through the instances, I'll find the actual XDebug section, and here it is. So this shows us that XDebug is installed, if you can see this part. Let's now go and run Docker Compose down, and then we'll target a different build. We'll target just the app build, which means that this shouldn't include XDebug. So docker compose -f docker compose dev.yaml down. One thing I will say here is if you specify the file name when you run it up, then also specify the file name when you run it down, because if there are differences between your normal Docker Compose and this Docker Compose file, then you might run into errors when you're actually running it down. That's happened to me a couple of times. Docker Compose is down. Now let's change the target for this build. So I'm changing it back to app. I'm going to run Docker Compose up. We need to run build because we are just wanting to build the app stage. So --build and then -d. And so if we look carefully at the build happening here, we shouldn't see the XDebug stage. As you can see, it's just gone to stage 8, which is composer dump autoload. Let's go and have a look at our Docker Compose file, and that is actually, yes, the last stage of the app build before we went and created this extra stage here. So that's all done. Let's go back to our browser, refresh, and if we search for XDebug, we only have 4 instances of the word XDebug now. And as you can see, we no longer have that XDebug section, meaning that XDebug isn't actually installed. All you see is just the environment variables and things which we are passing in through our config. Now this Docker Compose file is okay, but we can actually make it a little bit more flexible by doing what we did here, this kind of thing. Let me show you what I mean. So where we are targeting, we can do this, and then this will default to app, but we can have a build target environment variable, and so that means that each developer could have their own local .env file, and they could all decide if they want to have Docker or XDebug enabled or not, because some developers don't use it. So let me show you how we can create a local environment variables file, and then we can use that as part of when we run up Docker Compose. So where we have our .env file, just copy that. I'm going to call it local. And then say for example I actually want to target app dev, then what I'll do is say build target app dev, and then I can override the currently used .env file like this. Let me show you. This is the usual command that we run, Docker Compose. We specify the Docker Compose file, and then we say up, and then pass in the options build and then -d. So what I'm going to do before we call the up command is just say which environment variables file to read, and we can do that with --env file, and then we need the name of the file, so we're saying .env.local, and so this should be good. Let's give this a go. So as you can see, this time it's installing XDebug. Don't know if you noticed all the things there that were involved in order to install XDebug, and so like I say, with the command that we use here with the image that we started using in the last one, just makes things a lot simpler. We don't actually need to remember all those different bits of packages and things in order to install it. Okay, so XDebug, it is quite a lengthy install as you saw there, and it is quite an intrusive program, but we've got there in the end. I'm just going to refresh this. And as you can see, if we run XDebug now, we get all those instances of the word back, and also further proof that it is installed. So just to recap on what we did there, if we go back to our Docker Compose, we specified this environment variable here, build target, but we set a default value of app, we overrode that by having our own local .env file, which we called .env local, and we were able to specify that file when we ran docker compose up. And it's one of the options which you pass before you actually call the up command. So hopefully now that I've demonstrated two different stages of a multi-stage build, it should be all quite clear in your head now. One thing I will say about pushing to a remote registry is that you don't have to use the Docker Hub registry. Indeed, GitHub has its own container registry, GHCR, which stands for GitHub Container Registry, I believe. I'm going to be using Docker Hub because I've already got an account with them and I find it really easy to use. Anyway, this is the place that you need to come, hub.docker.com. Entirely optional if you want to follow along with this. If you don't want to create an account, then by all means don't create an account. But I will say about Docker Hub or any kind of registry is I found it really useful. Say for example, you put together an image, a real custom one which you use for specific projects and use cases, and you find it really handy. Say for example you're then working on another computer in a different environment, it's just easy to go and pull down your image from the registry and just start working straight away. So really good for productivity, I find. And the way you've got to think of it is just like a remote repository like GitHub or Bitbucket or whatever, except specifically for containers. Okay, so I've already got an account, so you don't need to see me set one up. Let's go over and start building an image and then pushing it to the registry. Now, one of the main reasons that I'm doing it is because for production, like I said in a previous recording, I don't want to be building my images this way. I basically just want to get them from a registry and build the container like that. And so here we'll target this one. What I want to do is build an image from this Docker file and push it to the registry. This needs to be a production image, so I am going to be targeting the app build and not the app dev build. The first thing I'm going to do is make sure that I'm logged in so that I can push to the registry. The way that I do that is docker login -u and then my username. It'll ask for a password. Okay, and so I'm logged in, and this means that I can go ahead, create an image and then push it up. Here is the command that we need, so docker build, so we're going to build the image. We are targeting the app stage of the build and we are tagging it as Gary Clarke PHP Composer. So the 1.0 is the tag and this is the repository and the name of the image. The Docker file that we're going to use to build it from, so we need the -f to specify which file, and it is in PHP Dockerfile, basically this. And then our context, where are we building from? We are building from the current context, so I'm in the very top level, the project root. Okay, let's hit enter and build that image. That all seems to have gone smoothly. If I run Docker images now, hopefully I should be able to go and find that. So I think somewhere near the top. Okay, so here we go. Gary Clarke PHP, no, that's not the one, that was a practice one. This is the one, Gary Clarke PHP Composer, and as you can see, I've tagged it with 1.0. And so that means that our final command is to actually push that image. This is the command that I need for that, docker push, and then the name and repository for the image and also the tag. So if I hadn't give it a tag there, what it would do, it would look for a tag of latest, but we've given it the tag of 1.0. Let's hit enter. Do a load of this stuff. Okay, great stuff. This is the tag for our image. Let's go over to Docker Registry, sign in and see if we can see it. So I'm going to sign in, that's my username. It's already got my password. Okay, so as you can see, here are all of my images. Let's click on this. Gary Clarke PHP Composer, tag of 1.0. And just having a look around the page just to see things of interest, we can see that if we want to push a new tag, it actually shows you what to do. Docker push Gary Clarke PHP Composer, and then we just give it a different tag name. So remember, your tag names, they can be numbers, they can be letters, or a combination of both. You'll see Alpine quite a lot, and that means it's like a lightweight, minimal image with not much software already installed. As a small addition to this one, it's not really related, but it seems as good a place as any to drop this in here. Thought I'd point this out to you. I've added a new folder, a tests folder. I've kept the code in there very simple. It's not for demonstrating testing, it's just to demonstrate how we can automate running the tests when we go and complete a pull request with this repo. So very simple tests that I've dropped in there, and one other thing that I've dropped in is actually the configuration, so the PHP unit.xml file. So you can find those both inside of the app folder, and then I've created a test folder inside of there and a PHP unit.xml. You might see this here, PHP unit result cache. I've actually git ignored that, so you won't even see that in your repo till you actually run some tests. Okay, so yeah, just thought I'd mention that. In this one, we're going to have a look at GitHub Actions and automated pipeline builds in a way which relates to the work which we've done so far. So the steps I'd like to go through are these. When we merge into the main branch, I would like the test to be run, and then I'd like to have the two images built, then log in to the registry, i.e. Docker Hub, and then push our images which we've built to the registry. So those images are, of course, our PHP image and our Nginx image, which will be built from the Docker files that we created. In real life, following on from that, the next step will be to push or deploy our code to whatever cloud service we use. I'm not going to do that because there's all different cloud services and all different configurations and way of doing things, which can be quite error prone. I want to stick to keeping this as a Docker tutorial. The first thing I'm going to do is I'm going to go over to the repository in GitHub, and I want to be able to add my Docker Hub login details so that when we go to do the build and the push stage, mainly the push stage to the registry, then GitHub Actions is able to do that. It has those credentials. And so the way we do this, if you go to your repository and you click on Settings, and then part way down the page you'll see this here, Secrets. So we're going to store it in Secrets. And there's the one for GitHub Actions. And so you click New Repository Secret, and you can give it whatever you want. As you can see, I have done this before. So for this one, I'm going to go with Docker username. My Docker username is this. So not sensitive information, but my Docker password is sensitive. I'll create a new repository secret for that. So Docker password. I'll just type in some gibberish here behind the scenes. I'll put in my real password, and then once you've done that, you just click Add Secret. And then once you've done that, you should be able to see your repository secrets down at the bottom there. Next, we need to create the file which GitHub Actions will read in order to perform these steps which we spelled out here. And so very important how you actually name things here. We need to create a folder called .github. So in the very root, .github, and inside of there you then need to create a folder called workflows. Again, important how we actually name these. If you don't name them correctly, then GitHub won't know where to find the file. Then in here we can create YAML files. So as long as they are YAML files, it doesn't matter what we call these. GitHub will just go over them one by one in sequence. And so if you had 3 YAML files in there, it would read 3 YAML files. We're just going to need the one. I'll call this deploy.yaml. That's quite a common name to see for this kind of thing. So again, I'm not going to make you watch me type out a deployment file line by line. That would get very boring. I'm just going to paste in something which I've used earlier and which I know that works. And we'll go through this line by line. So I'll just make it a bit small so everything fits on one line. Sorry if the text is a bit small for you. Okay, so the way this works is you give your action a name, and then you say the conditions under which you want the jobs in this file to be executed. So here we specify just the one condition, and we are saying on push branches main. What does that mean? It means that when we push to the main branch, then we want the jobs in this file to be executed. And so you can specify multiple jobs in here, but I've only got the one. So the next key is jobs, and I've named it build. You can name your jobs whatever you like. We're just going to call this one build. And then the steps which we include in this build job are going to tell GitHub Actions exactly what we would like it to do when we push to the main branch. And so this first bit runs on from the GitHub docs. A runner is a server that runs your workflows when they're triggered. Each runner can run a single job at a time, and GitHub provides Ubuntu, Linux, Microsoft Windows and Mac OS runners. So we've gone with Ubuntu latest. Okay, so this next line uses Actions checkout v3, again from the documentation. Actions. An action is a custom application for the GitHub Actions platform that performs a complex but frequently repeated task. So this is a complex but frequently repeated task. Someone's gone to the trouble of creating an action which will do it for us, and so that is why we are using this. Let's talk through the steps I've created, so you can actually name them, which makes things quite self-explanatory. Here we are installing Composer dependencies, and then we are running the test. So we're not installing them inside a container, we're doing this sort of inside of GitHub Actions and running the test, because remember these are dev dependencies and I don't want my dev dependencies inside my container. If we go back to our Composer JSON file, you'll see in the script section here I just came up with this script name, which is an alias for vendor bin PHP unit, and so if you wondered what that was that you saw there, then that's basically that. And then we come on to the interesting part here, and for this we are building our image, we are targeting the app part of the Dockerfile, we are tagging it with Gary Clarke PHP Composer 1.1, so I'll change this to 2 so you can see the difference when we go and look at this on Docker Hub. And again, we're specifying the file from which to build the image from. And then we do the exact same thing for our Nginx Dockerfile. Docker build, we give it a name and a tag of 1.0, and we're saying use this Nginx Dockerfile in order to build this. And then we are logging in to Docker, logging into Docker Hub. As you can see, this is where we get to use our secrets which we specified, and so the way to use secrets inside of one of these files is like this. And so it is secrets dot and then the secret name. We've done the same thing for the Docker password. The command itself should look familiar to you because it's one that we ran before when we were pushing our image up. You docker login -u, then pass the username -p means password. Okay, and then next, this is quite interesting. This is where we actually push those images. So I'm just going to change this to 1.2 because that's what we've made it. So we're pushing our PHP Composer image, and then we're pushing our Nginx PHP image. Behind the scenes, I've committed those changes, so I'm now going to push this up to GitHub. Okay, so excuse the really long branch name that I've used here, but I'm naming the branches after each lesson, and the lessons need to describe what we're actually doing in each lesson, so that's the reason for that. Let's hit go on this. Okay, cool. So you'll see that I pushed to this branch here, GitHub Actions Automated Pipeline Builds. That doesn't mean that our build will start yet, because if you remember the rules which we set for this, it's when we push to the main branch. So let's go over to GitHub and we'll do that manually. Here I am in the Docker PHP repo. As you can see, I pushed this change a minute ago, so I can go and compare and do a pull request. So I'm going to create a pull request to pull this branch into the main branch, and that should kick off our GitHub action. I'm not going to leave a comment for this, I'm just going to start it rolling. And then we just need to merge this pull request, and that will kick everything off. So this is a typical kind of workflow. In reality, there would be some protection on the main branch so that a pull request is always required. I didn't actually have that in place, but I kind of mimicked it. If you want to learn more about collaboration with Git and GitHub, then I've actually got a full course on the subject at garyclarke.tech, and that course is free for my mailing list subscribers, so be sure to check that out. Let's go ahead and do this. So I click merge PR, then I click confirm merge. The GitHub Actions blah 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 branch can be safely deleted. Okay, let's delete that. And then we need to go up at the top. You'll see these tabs. We want the Actions one. And as you can see, we have a GitHub action has been kicked off. And it can take a while because there's quite a bit of setup and stuff like that. Sometimes with like production builds, these things can take, quite a few minutes. Okay, and it is complete. It says it took 55 seconds. Let's go and have a look at our build and make sure that there weren't any errors. We've got a green tick, but always check just in case. And so the kind of things you're looking for which can fail are things like running your tests. So we're going to look at them. We can see one test, one assertion. Great stuff. We've built our images. Let's have a look, pulling all the layers. You'll see these little bits of red here, but these are just warnings. There's nothing in there to be scared about. You'll notice here we're installing all of our dependencies, our Composer dependencies. I'll not bore you by going through absolutely everything, but you can see here each step of the build with a little tick to say that this has completed successfully. And so if this has completed successfully, then that means that we should see our images on the Docker Hub. Let's go and check that now. So over on Docker Hub, if I give this a refresh, okay, I can see my images which were pushed 2 minutes ago. So we have my Nginx PHP one and our PHP Composer. Let's just go and check that this has the correct tag. Yep, so we have version 1.0, 1.1 and 1.2, which was the one that we pushed 2 minutes ago. This is really cool. And if you're wondering why we did that as part of our code merge, it's like I said before, when we are pushing to some cloud computing solution in production, I don't want to be building those images. What I want to do is grab those images from the registry. So every time we merge our code now, we know that we have the latest version of those images. So that's what we can use in our Docker Compose file for production. And that's something that we're going to have a look at next. Congratulations on making it this far. We've covered a lot of ground and you've taken in a lot of information. So sincerely, well done. If you haven't liked the video so far, then make sure that you do that now. You're probably wondering what are our next steps. The good news is I am recording bonus material. I'm going to upload that to garyclarke.tech. Don't worry, it will still be free. The subjects which I'm covering at the moment are multiple Docker Compose files for overrides, and I'm also going to do some stuff on framework integration. I'm still taking requests, so if you have any of your own, let me know what those are, and I will see you over at garyclarke.tech.